Hey gang, welcome back to our discussions about RIP version 2. Right now what we want to do is we want to entertain exactly what goes into doing additional manipulations with regard to our prefixes. Previous in the last video we looked at how we could do summarization to affect traffic engineering. There's also other methods that we can use to affect which prefixes are going to appear in our routing tables. And first and foremost, I want to entertain the idea of the offset list. Now, remember in our scenario, let's just do a refresher and let's make sure that everything's good to go. Based on R22, and I beautified or prettified the drawing for us, but based on what we're learning on R2, we should be learning those /21 prefixes that we're actually advertising for the loopbacks originated on R1. All I want to do is verify if that's indeed the case. And what we'll do is we'll do show IP route, RIP, and let's look for 11. And what we should see here is that we are advertising that /21, and that /21 is being load shared across 2/1 and 2/0 on R22. We can verify that we have that entire process going on via a trace route. So let's say trace route to 11.11.0.11, and we'll notice that we're going to load share. Now, we're advertising a /21 prefix, but keep in mind that /21 would give me 8 individual networks that I could actually advertise, but we're only advertising 4 of those, actually 5 of those now. So it's going to be loopback 100 all the way down to loopback 104. Now, recognizing that, like I said, if we were to add interfaces at a future date, those interfaces, if they were advertised into our routing protocol, would also be summarized. And that's going to cause us some issues here. Now, the first thing I wanted to point out also is the fact that if we go to R1 where we did our redistribution, and I type show IP route, what I want to illustrate here is that when we do summarization on RIP, it does not automatically create a static route to null 0 for the summarized range. Now, that's going to be a loop prevention tool. I just wanted to point it out because I should have mentioned it in the previous video series, where all of the other routing protocols that we're going to work with when we do summarization will generate a static route to null 0 in order to prevent the possibility of loops. Because keep in mind, we're going to be sending information to this router based on that summary, possibly for prefixes that don't ordinarily or do not exist in our topology. So if they were to arrive here and they don't exist, we would want to be able to black hole those or send them to the bit bucket. And then we do that through this auto-created static route. Now, the other thing that we mentioned is that we were learning the /21 from both R2 and from R3. Now, we're learning them from here and here via the serial connections that we have on R22. Now, we're learning them and we're placing both of those prefixes in our routing table, and we're doing this load sharing process. Actually, I'll illustrate that once more. We're doing this load sharing. We'll do IP route 11.11.0.0. And what we're going to find here, let's see, no, that's on R1, on R22. Yeah, we're doing the load sharing here because we have both of those prefixes. Now, both of those prefixes are being learned because they have this matching administrative distance, which we know is we're learning them from the same routing protocol, and they have matching metric. Now, that's what I want to alter. I want to change the behavior of the system, and I want to be able to alter it such that I'm going to pick a link over another link. That's one of the best ways that we can use to illustrate this. So right now, what I want to do is I'm going to pick serial 2/0 as my primary interface to use to reach destinations. Now, we looked at how we can manipulate this through summarization. What I want to look at right now is how I can manipulate this through metric manipulation. So let's entertain exactly what's going on. So first of all, what I'm going to do is I'm going to go to R3, since that's the device where I do not, or that's the device that I want to modify its current behavior. And what we're going to do is I'm going to go to interface. Excuse me. Let's take a look at our interface. So do show run interface serial 2/1. Is that the right interface? Yes, that's the one that's leading down to 22. Do show CDP neighbors out of serial 2.1. And yes, that's what's connecting me to R22. But where I want to make my configuration change is I want to make it under my router RIP process. And what I'm going to do is I'm going to execute a command called an offset list. Now, an offset list allows me to offset my metric. Now, the rule is I can only add values to my metric. I cannot make my metric lower or less than what it actually is, but I can add to it. Now remember, in our theoretical conversations, a prefix in RIP is considered to be a dead prefix when its metric exceeds when it reaches 16 hops. It's considered to be a dead route. So 16 hops in the context of RIP version 2 and RIP version 1 is considered to be a dead route. Now, we can continue to change that, but keep in mind, if we make it greater than 16, we're not going to advertise that particular prefix. Now, what I want to do is I want to highlight something. So what I want to do is I'm going to say offset list, and notice that I have the capability of specifying an access list. Now, the one thing I want to point out here is that 0 means I'm going to match all networks. So if I come in here and I say offset list 0, what I'm going to set here is I'm going to say anything that's outbound, I want to offset it by a value of 3. Going out of interface serial 2/1. Now before I hit enter, let's take a look at what we are learning. So let's go back over to R22, show IP route, and let's pick one of these, 10, or let's say 11, 11, 0, 0. Well, we're learning it as a /21. We're learning it via these two interfaces. Both of these interfaces are learning it as a metric of 3. So it's 3 hops away from 22. So if we were to follow that, that would be 1, 2, 3 hops. 1, 2, 3 hops. Now what I'm going to do is I'm going to come in here now and I'm going to say I want to add a value to anything that I learn via this interface. Thus I'm going to take it from 3 and I'm going to increment it by whatever value I say that I want to add to it. So let's take a look at exactly what that looks like on R3. So I'm adding 3. Do clear IP route star. Now let's cut over to R22 and see what happens as a result of this. Now notice I only have the one prefix, 10.1.222.2. I learned it from 10.1.222.2. So that's going to be R2, and it has a metric of 3. So let's take a look and see what we've got here. See if it's just an issue of waiting for it to cook out. Nope, it's not there. So let's see what our trace route results in. So trace route 11, 11, 0, 11. Notice I'm going through R2. Now I'm not going through R3. So let's see what is being advertised to us on R22 from R3. What I'm going to do is I'm going to go to interface serial 20 and I'm going to shut that interface down. Show IP route 11, 11, 0, 0. And now notice I'm on serial 2.1. I'm learning it, and it's telling me my metric is now 6. So it was 3. I added 3 to it, so that's giving me a value of 6. So now what we illustrate here is a method or a means by which I can actually control what is going to appear in my routing table based on metric. So offset allows me to be able to increase my metric. So the route that I want to be less preferred, remember, lower is better when it comes to hop count or any other metric with regard to our routing protocols. And the idea is that by making one arbitrarily higher, I can actually have the system pick that particular prefix and only use that one for the purposes of load sharing. So that one link to use it that it's going to learn with the lower metric. So again, it gives me the capability of being able to granularly alter the behavior of my routing protocol. Now, like I said, I can only increase the metric. I can't decrease the metric. And higher is worse, lower is better. So when we look at this, again, keep in mind that this, more often than not in an offset application, if I want to prefer one link over the other, I'm going to do the offset config on the link that I do not want to prefer. Now, also I want to point out the fact that these are directional. When I did the configuration on R3, I said out. Now, what would happen if I went to R22 and said that I wanted to go to S2/0 and apply a value inbound? Well, let's take a look at that. Let's go over to R22, config T, router, RIP. And what I'm going to do now is I'm going to say offset list 0 in, and I want to add 3. And what I'm going to do is I'm going to say anything that comes into serial 2/0. And now when I look at this, show IP route for 11.11.0.0, what we're going to see here is that I'm learning a prefix from 6, but I left the interface turned off. So show IP interface brief, exclude assigned addresses. Yes, I left it off. So let's turn it back on. Give it time to learn some prefixes. Was that interface still on? Show IP interface brief. E assigned addresses. Yes, now both of my interfaces are up and running. So let's take a look and see what's going on in my routing table. Show IP route. RIP. Well, this is interesting. Observe what's actually showing up in my routing table. Well, notice for my 11.11.0.0, I'm still only seeing, I'm seeing the /21 that we're advertising, but I'm only seeing an individual link coming through. So the question now is what did my modifications do? Let's look at that. What I did is over here on R3, I said add 3 to the metric when you send it to me. Then here on R22, I said add 3 to the metric when it arrives. Now my hope is that 3 and 3 would allow me to start load sharing again. But what we're seeing here is counterintuitive. Notice I have my 6, my serial interface, 2/1 is still the one that I'm preferring to have reachability on, even though I've brought those interfaces back up with regard to S10, I mean S2/0. So let's look at what's going on here. Well, the easiest and fastest way to troubleshoot this is going to be to go on to R22 and let's shut down 2/1. Interface serial 2/1, shut. Do show IP, interface brief, E assigned. We can see it's down. Do show IP route, RIP. And let's see what we're learning. Well, let's see here. We have some stuff going on. Well, notice here where we have 4. Let's take a look at the 11. Well, the 11 says it's 6. So we have 6 and 6. So maybe it was just an issue of waiting. No shut. Clear. IP route star. Show IP route for 11.11.0.0. Well, now we're still preferring 2/0. Well, did we leave something off? Have we broken something? Show IP interface brief. Nothing there. Let's go up to 2 and 3 and let's make sure everything's going to go. Show IP interface brief. Still good. 3. Do show IP interface brief. E assigned. And all my interfaces are up. So that's interesting. So we added 3 on both sides of the scenario, 1 on each link. And let's see what's going on again. So right now, let's go back over to R22. Again, maybe it's just an issue of waiting. You know, with RIP, it seems to be a battle of being able to be patient. Show IP route RIP. Let's take a look and see if we can see that 11. There it is. And now we're load sharing. And we're both on 6. So again, I'm just trying to illustrate the point that we have to be exceedingly patient when we're working with RIP. RIP is still in the blueprint. Is it going to be a huge topic? No. But is it going to be a topic that they use to cause us problems with regard to other routing protocols, like during our redistribution processes? Heck yes. That's the reason, in my opinion, it's still in the test. So what we need to pay attention to here is understanding exactly what's happening with regard to our prefixes and how we can do their manipulations using offset lists inbound and outbound. Now there's one other thing that I want to clarify here, and that is that I did an offset list using access list 0, which by definition matched every source. Now when we look at using offset lists to do these manipulations, one of the main things that we have to understand is the fact that, like I said, we can only increase the metric. We can do it inbound and we can do it outbound. But if we use an access list like the one that I just used, where I'm using 0, it's going to match everything. Also, if I cite an access list that doesn't match anything, it's still going to match everything. So it doesn't have to be 0. I could have come in, and let me illustrate that. I'll go over here to R3. Do or show run section router, and what I'm going to do is I'm going to modify this, and I'm going to say not 0, I'm going to say 22. Config T router RIP. I'm going to say no offset list out serial 0. Then what I'm going to do is I'm just going to plug it back in, but this time I'm going to say 22. Do clear IP route star. Do show IP access dash list, and I have no offset list 22. Now let's look at this. So over here on 22, show IP route 11.11.0.0. And let's see what we've got going on now. Well, let's see if everything stays refreshing. So matching 0 is going to match every prefix. Matching any undefined access list is going to have the same net result as matching 0. Now, why do we have the access list? Well, let's take a look at that. All right, while this is percolating, let's go over to R3 again. Let's do this. Config T router RIP. And what we did was I did offset list and I matched an access list. Well, notice it says access list of networks to apply the offset to. All right, well, this is interesting because what I'm going to do is I'm going to say 22 and I'm going to say out. Well, actually, we've already got that config in, so let's go ahead and create access list 22. So access list 22, permit, and what we're going to do now is let's play around with this. Let's say I want to do this for 11.11.0.0, and notice right now what we have is we have wildcard bits that we can match on exactly. So let's say 11.11 has to match. Let's say 252, actually no, we're doing 248. 255. Let's see what happens now. Do show access list. Do clear IP route star. And let's see if we can get any hits against this access list. Well, I got one match. Okay. With that being said, now let's go back over to R22. Show IP route. See if we see anything with regard to that 11 network now. Well, here it is. We have the 11 network, But what we're seeing here is that they're still matching. We're still load sharing. Can demonstrate that here with a trace route to 11, 11, 0, 11. We're still load sharing. We haven't changed anything. Our metrics are actually the same. That tells me that we're load balancing, or like I said, load sharing, equal cost multipathing. But the main point here is what prefixes got manipulated. So if I come in and I say show IP route, let's look at another prefix. Let's look at one that didn't get fixed. So what we'll do is let's look at the output here. And what we're going to find is notice we're learning prefixes via serial 2/1 that have metric counts of 1, metric count of 3, 3, 3. And the only one that we're going to see that's going to have that 6 attached to it is going to be the one that we're learning from 2/1 that has the 6. Because what ends up happening is the access list, the ACL that we created, matched a network. Anything that matches that network is how or where we're going to apply the offset. So this gives me the capability of being able to select a particular network or group of networks that I want to have offset applied to while ignoring the others. The danger of using the access list 0 or an access list that is undefined is that it's going to match everything, and everything is going to be manipulated with regard to altering its metric. So again, inside the context of the CCIE, when told we want to be as granular as humanly possible because we don't want to affect a route that we have been told to manipulate and then accidentally manipulate another route whereby we may have the possibility of having it no longer appear in our infrastructure. Because I can use this for the purposes of eliminating prefixes. Let's entertain that. So right now what I may do is let's go back over to R3. I want to continue to, let me get rid of this, cut. I'm going to continue to use R3 as my illustration. Let's see what's going on here with this access list. Notice it's constantly being matched. So now, let's play around with our offset command. So what I'm going to do is I'm going to go back up to my router RIP. Under the confines of router RIP, I'm going to look at my access list, not my access list, but my offset list. And let's say I did not want to learn any prefixes coming from R3. So what I can do is I can come up here and say, let's change this to 16. Out. Do clear IP route star. And then what we'll do is we'll cut back over to R22, show IP route 11.11.0.0. And we should, at this juncture, only see prefixes coming into us from serial 2.0. Now the reason being is that we made the metric on the prefix for 11.11.0.0/21, we made it infinite. So it's not actually being advertised. Let's cut back over to R3 and end. Let's do a do or debug IP RIP. Let's see what happens. Well, I'm going to do the same thing on 22. Debug IP RIP. Notice right here, we have, I'm going to U all this, it's getting too much. Let's scroll up until we find that 11.11 prefix. Notice here, 11.11 metric 16. That's building our updates to send out, and we're sending it out serial 2.0 towards R22. All right, now let's go back, let's cut over to R22 and do a UAll. And now let's see what we're actually learning as it goes through. Let's see, are we learning anything about that 11? Notice right here, 11.11.0.0/21 is inaccessible. Now the danger of this is, should I lose my link on 2.0, serial 2.0, should something go down, what's going to end up happening now is that I'm never going to learn these prefixes because they're being advertised to me, and RIP is considering them inaccessible based on the fact that their hop count is greater or equal to 16. So again, stay focused on what it is you're trying to accomplish. Make certain that when you do want to do manipulations with regard to these offset lists, you pay attention to the fact that we can only increment up, we can't take it back down. And there is the danger of being too uniform, i.e. applying it to an entire interface, whereby our actual instructions may be to manipulate something that's specifically associated to a given network or a specific prefix. So with that said, what we're going to do is we're going to look at some more components associated with route filtering in the other videos, and I'll see you guys there. Bye-bye.